And I suppose on days like today and yesterday, it's not such a bad thing to be cooped up inside, right? And yuck out. I still went for a run this morning. I was debating and I'm just like, well, whatever. Anyway,
How long?
I don't know. I mean, what I go for probably 5 to 7 miles ish. Just enough to kind of get my energy out so that I can move for the day.
I won't be able to move every day.
Yeah, but you know, I've been doing this for decades, right? Yeah, I've been absolutely doing this for decades. So it's just part of my life. And I'm actually like not well if I don't get my energy out in the morning. I have a hard time all day long. All right, so I want to start out by making a few announcements, which of course, as you know, I make them again and again and again, because in case you miss it one time, hopefully you won't miss it another time. My first announcement, and I'm just going to do this by sharing my screen, hopefully, but not quite yet. Hold on one second. Okay. Just have to make it work for everyone on Zoom too. All right. So number one announcement is if you go to the class Moodle page and go under class activities, you see this class activity 1. Many of you have already handed it in. If you have, your grades in the grade book. Okay. If you haven't, not a problem, but it is due by class time tomorrow, either via email or just bringing it here. I will add that if you don't hand it in on time, it's a 0 in the grade book. But remember, I do drop the 2 lowest class activities anyway, so you know, it won't hurt you, but I definitely recommend you do that. So once we leave class tomorrow, you will suddenly see right here the solutions posted. Okay. I wait to post the solutions, obviously, until I'm done collecting them. Imagine that. So number one reminder, you got to get this into me tomorrow by class time. Number 2 reminder, here I'll show it to you from this perspective. In your online homework, your first lesson is due tomorrow by midnight. Okay. If you don't get it done, then you will still have the opportunity to go in and do it for practice, but it will not count in your grade book. But I keep assignments open for practice in case people want to go back in, and because they just had so much fun the first time around or some such thing like that. But please be sure you get this in by midnight. You submit each question, but at the end of the assignment, you don't have to hit submit. It just saves as you go. Okay. So I just want to be sure that everyone's clear on that. This Friday, ooh, there's a chat. Will you be handing the worksheets back? Yes. Tara, thank you for asking that question. So those of you who hand your physical worksheets in, like if I get a hard copy from you, I will give them back to you. If you email them to me, I don't print them. I just grade them from looking at the email and then record the scores. But at that point, you can then see what you did versus, you know, what the solution is. Yes, this is the worksheet from last Friday. The other thing that I want to say is I am giving you another worksheet again this Friday. I'm not going to take class time this Friday to work on it, but I will be handing it out, and then it'll be due the following Wednesday again. Okay, so there is another upcoming worksheet. Those of you who Zoom in and don't physically come to class, I will be posting it on the Moodle page once again. So you'll always have multiple ways to access it. Now, some people have said that they've had difficulty printing it from the Moodle page. I'm not asking you to print it. If you write, if you don't physically come to class, you can just literally, write out your solutions on a separate sheet of paper and email that to me. I'm not very particular. I don't like assuming that everybody has endless access to technology. So number one, you have two things due tomorrow. One of them is due in class or by class time via email. And then the other one is the online homework due by midnight tomorrow. Okay. So the second thing that I want to say, and I'll be reminding you of this, a week from tomorrow, next Wednesday, we're only Zooming class. Okay, I've got to be in Billings for like a 3-day long meeting. And it's more important to me to teach class. And so since this class is run blended anyway, we're all just going to Zoom. So if you want to come here and Zoom from the room, you're welcome to, but I have a feeling for a lot of you who come here from the mountain campus, it'll at least save you somewhat of a hassle next week. But I'm just going to leave the meeting and, find a bit of carpet somewhere in a corner and we'll do math. That'll be the best part of my meeting. So that's just for next Wednesday. That is it for announcements. I guess my one other comment to all of you is if you have questions on the online homework, you can ask me in class, okay? I'm super happy to answer any and all questions that you have. All you got to do is ask. Okay, some people have already messaged me through the My Open Math asking math questions. I'm on it. Like that's the best part of my days is getting to do math with all of you. So seriously, do not hesitate to ask any and all questions. Okay, but I'm happy to go through anything in class that you might also have a question on. Cool. Awesome. So what I would like to do is first start out, and by the way, the class activities, what I want to say is, I want you to work on them as a group. You don't have to, of course, but please make sure that you understand what's going on. And then I'm happy to clarify anything there as well. Okay. The only thing that I'm not willing to help you with is your text. Imagine that. Okay. So yeah. Cool. You're all very quiet. Is it just that kind of a day? I know. I think it's just, I just love it. All right. So, you ready to do some math? That ought to pep you all up, right? Does anyone have anything fun to share with the class? I'm always up for being amused. No? Okay. Well, then let us move forward. So, do you remember with the Venn diagrams? Hopefully you do, because it just wasn't that long ago. But do you remember with the Venn diagrams? So for example, that first class activity on the back page, you have to fill in the Venn diagram. I think it's like math, English, and history majors or something like that. You always start in the innermost region, okay? Okay, you want to work inside out. So you think of that in terms of like the order of operations when you had those really long things that you had to compute for no good rhyme or reason. You always want to keep that in mind, that you want to start in the innermost region or the most restricted and then move out, okay? The same thing follows here when we're dealing with the multiplication principle. So as you saw yesterday, we kind of went from 0 to 50 pretty darn quickly, right? At first, we were just wondering how many different meals we could have at a restaurant. And then suddenly we're finding PIN numbers and it's like, whoa, you have all these restrictions thrown at me, okay? And I just want to emphasize that, you know, I try to ease into those as much as I'm able. But the key thing is start with the most restrictive place first. Okay, that's my best advice. So our last example yesterday was that we started with a 4, we couldn't end in a 9, and repetition was okay. So where I'm going to pick up is to get it to be a little more of a pain. And now I'm going to say, again, we want a 4-digit PIN. It's continuing from where we left off, and it must start with the 4. It cannot end in a, I don't know, what's your least favorite digit? 7. Wow, I got a reaction. I just love it, even if I had to bring something up like that. Isn't it funny how we all have like our favorite numbers and least favorite numbers? Anyway, okay, it must start with a 4. It cannot end with a 7, and no repetition. This is about as picky as it's going to get. Okay, so I want you all to follow my steps along with me, because again, this thought process is what's going to carry you through. Okay, we have 4 really important decisions to make. Again, we're just picking up where we left off last time. We're picking a 4-digit PIN. We know that there's a total of 10 digits. Okay, what I recommend you do is you write your restrictions underneath. So this must be a 4. This cannot be a 7. And all throughout, no repetition. Okay, I strongly recommend you do this. And one of the things that I really want to get across to everybody is hopefully you see that I don't just jump to an answer. Okay, I work through and problem solve to get to that answer, and taking those steps is really important. All right. So if I'm telling you that we need to start with the most restrictive place, what is the most restrictive? I mean, we've got restrictions on all 4 of these digits, essentially. Good. This gives us the least amount of wiggle room, right? Telling you it has to be a 4. Oh my gosh. Okay. So do I put a 4 up here? Be careful. Remember, down here are our restrictions. Up here are the number of ways to choose. So going back to what we did yesterday, in how many ways can you pick a 4? One way, you pick the 4. There's only one 4 to choose from. Is that okay? Okay, if you didn't see it at first, that's fine, right? Questions are what leads to clarity. All right, now I've got to deal with what's next. What is my next most restrictive place? I mean, here I've got no repetition, here I've got no repetition, and here I have cannot be a 7 and no repetition. Would you grant me that this is my next most restrictive place? Okay, so let's think about this. We have 10 digits. What are we being told? It can't be a 7. So do you agree that automatically nixes one of my digits? Okay. But we also have the restriction of no repetition. So what else does that tell us? It can't be what? A 4, because we use the 4 already. Okay. So given that there's 10 digits total and we can't have a 7 and we can't have a 4, how many choices do we have for this next digit here? 8. All right. And the reason why it's an 8 is because it can't be 7 and it can't be a 4. You don't have to write this reasoning down, but I sure want to put it in the notes in case you have a question going back to it. Okay, now yesterday we saw that there was a 9 here because we didn't have the repetition business going on. All right, this is where it gets funky for people. Okay, it's so natural to say, oh, no repetition, let's just keep counting down. But we can't do that. Okay, so let's go to either one of these here because no repetition is really the only thing going on. Okay, so let's just go here first. What are my restrictions for this digit here? No repetition. We start out with 10 digits. How many digits have we used? We've used 2 digits. So how many choices do we have for this one? We have 8 again. We have 8 here because no repetition. Now for this one, my only restriction again is no repetition. You start out with 10 digits. Now how many digits have we used? 3. So now how many choices are there here? 7. It's really common that when you write an 8 here that you immediately think then this would be 7 and this would be 6. And that's really good thought process. But again, this is no repetition and we have used 2 digits. And then this is no repetition and we've used 3 digits. So as it turns out, there's 448 ways. Yeah.
So when you're doing it, you want to do all the special conditions before you do one.
Yes. Yes, because once you're told it has to be a 4, if you didn't start out with that, you might have picked a 4 in here, right? Right, and no, it's so if you went to the next box first, you're right, you would have put a 9 because you would have said no repetition. But that would have, but you honestly don't have 9 choices because there's also another hiccup that goes on right here. Get rid of all the special cases. So that's what I mean when I say start with the most restrictive. All right, so let me ask you a slightly different question. What if we're in Montana? Oh my goodness, we are in Montana. Cool. In Montana, the area code is fixed for now. I wish it would always get to stay that way. Isn't that crazy? One area. Huh? Well, not if population keeps increasing. We're going to run out. Huh? Yeah. Okay. So the area code for right now is fixed. Okay. So what if I ask how many phone numbers are possible if it can't start with a 0 it must end in a 7. And no repetition. And you're like, oh my God, why are you such a pain with these things? It's just so that we have the opportunity to play. Do you agree we have 7 choices to make because outside of the area code, it's a 7-digit number? Okay, so I'm going to write my restrictions. No 0. Must be a 7. And for all of these, no repetition. Yeah. It's just made up. You really can. Yeah. No, this is just a stupid math problem. Yeah, it makes it easier to remember anyhow. So I have this not starting with a 0, but this is a seriously outdated thing because when I was growing up, if you press 0, you get the operator and you'd actually talk to somebody. But things like that just, I don't think exist anymore. I'm pretty outdated here. All right. So what is the most restrictive place here? Must be a 7. My goodness. They're telling us what to do again. In how many ways can you pick a 7? One way you pick it. You with me this far? Okay. What is my next most restrictive place? No 0. Is that my only restriction here? No. What other restriction do I have? No repetition. So I start out with 10 digits and I'm told, hey, you can't use a 0, but what else can we not use? The 7. So how many digits do we have to choose from? 8. All right. From here on out, my restriction is no repetition. So we start out, we have 10 digits. How many digits have we used that we cannot use again? 2 of them. So how many choices do we have for here? 8. Note, this is an 8 because no 0 and no 7. And this is an 8 because no repetition and we've used 2 digits. All right. Started out with 10 digits. We've now used 3. So how many choices do we have here? 7, then 6, 5, 4. And if you multiply across, you get 53,760. As if we care. Well, the thing is if you can have 0, 0, it's 10 on each. It's 10 on each, right? So it's just 10 raised to the 7th power. All right. So let's change this up a little bit. Suppose I have 5 books. And I want to find the number of ways to arrange all of them on a shelf. Okay, I've got 5 books. And let's pretend I have like a shelf right above my desk. And I want to put all 5 there. Okay. Notice I'm using the word arrange. So presumably it's slightly different if I have, the history book next to a math book, next to a sociology book, rather than like bebopping 2 of them. So when you say the word arrange, implicit in that statement is the order matters, like somehow it makes a difference. Okay, it's all about the feng shui or some such thing like that, right? Okay, so Do you agree we have 5 choices to make? This is kind of like the people sitting in a row when we were talking about the televised talk show yesterday. How many possible books could I put on the left side? 5, right? But I'm going to put one there. So how many possible books could I put right next to it? 4, but I'm going to put it there. Then 3, then 2, and then 1. This is equal to 5 factorial. I mentioned that factorial yesterday. It's when you take a number and multiply by 1 less all the way down to 1. And you'll see that that's equal to 120. Similar scenario, suppose I have 5 books, but now I want to find the number of ways to arrange 3 of them. In other words, only 3 are going to fit on my shelf and the rest are going to go on my floor. And if you've been to my office, you'll know that this is a very consistent thing. Okay. So now how many really important choices do I have to make? 3, good. I'm only placing 3 of them on my shelf. Okay. How many choices of books do I have to go right here? 5. But I'm going to put one there. So how many possible books can go next? 4, and then 3, and then the other 2 will go on the floor. So notice that cut them in half. Okay. So what I'm going to do right now is I'm going to give you a definition of something. And I'm going to tell you that this is nothing that we ever use. Isn't that great? I'm telling, because we have the multiplication principle. Have you all heard of the term permutation before? Maybe. Okay. So it's a term that can be used along with the multiplication principle. But honestly, what we do is we use the multiplication principle to solve these things, not permutations. I am going to show you this though, because in case you read the book and as you go further on, you might encounter permutations in your life. Okay. I will say that starting here and in the next lesson, you are going to need a calculator. Remember, if you have not checked out a calculator from the library downstairs, I would highly recommend you do that instead of spend money on a calculator. But you do need one that does a lot of different computations, one of them being what we call combinations and one of them being permutations. So please be sure that you get the calculator soon. I'm going to show you this. The only time that I ever actually compute things using the permutations, though, is when I teach this class the one day. I never use them in practice because I think that the multiplication principle is a lot more intuitive. But when we talk about a permutation of, say, n objects taken R at a time, this can be written as a permutation n comma R. And if you want to compute that, it's by hand, it's n factorial divided by n minus R factorial. I never use this formula. It always blows me away when people actually go back and use this on tests because it's like, you can, but why are you making life so much more difficult for yourself? Okay. If you're going to use permutations, what you're going to do efficiently is use this thing on your calculator. And I'll show that to you. I'll bring a little calculator tomorrow. Okay, now what is a permutation? A permutation is when you want to count the number of ways that something can be done when the order matters and no repetition is allowed. The reason why I don't ever use this technique is because the multiplication principle, in other words, the way we've just been solving these things, always works when order matters. You don't have to worry about the question of, is repetition allowed or not? And we've seen with examples thus far that it really does make a difference about whether or not repetition is allowed. So just to kind of show you this pertaining to our previous example, and you might be like, well, Lauren, if you never use this, why are you showing this to us? Because you do have to use it when order doesn't matter, because that turns into a combination. But don't worry. Hopefully you trust me by now to know that I'm going to do so many examples. Okay, but let's check this out. This first one. Do you agree we had a total of 5 books and we wanted to arrange all 5? Okay, so N is the total number, R is the number that we wish to arrange. So using this formula that I just wrote down here, we have P of 5, 5, right? N is 5, R is 5. Well, plugging that into our formula, we have 5 factorial divided by 5 minus 5 factorial. Do you see how, given N and R being 5, I plugged it into this formula? Now, one thing that I have to note is 0 factorial is 1. So do you agree I have 5 factorial over 0 factorial? Which is 5 factorial. And isn't that precisely what we got here? Now, in this second case that we looked at, my N was equal to 5, but what was my R? Here, we only wanted to arrange 3 of them. Note our solution here. So here, R was 3. So we have P 5, 3. If I plug that into the formula, do you agree we have 5 factorial divided by 2 factorial? And we could write 5 factorial as 5 times 4 times 3 times 2 times 1. And we could write 2 factorial as 2 times 1. Conk, conk. Look what we're left with. Whoa, 5 times 4 times 3. Isn't that exactly what we had before? How nifty is that? Again, I will show you this on the calculator tomorrow when I actually bring it to class. Okay, I mean, I guess I do have this calculator here today. So for those of you who have like a TI-83 or a TI-84, it's a little more quote unquote complicated the way you get to it, but here I'll show you. See this math button here? Okay, so the way that you would do this is it's NPR, which National Public Radio. Okay, so you have to say like what immediately comes to mind. But what you do is, if I wanted to do like 5, and 3, you enter the 5 first. You hit math. Do you see this PRB thing here? PERB. You go over to PERB. And do you see how number 2, it says NPR? You hit that, you hit 3, and lo and behold, you get the same 60. I'll show you tomorrow with the calculators that we have for you to check out of the library. Okay. So let us play with just a few more examples here. Okay. So this is kind of a cute one. And I like doing this one because the first time I did it, it taught me something I didn't know. Okay. So radio station call letters. Okay. Well, they're 4 letters long. Did you know that all radio station call letters either start with a W or a K? I had no idea of that. And it's actually by which side of the Mississippi you're on. So if you are east of the Mississippi, they all start with W. And if you're west of the Mississippi, they start with K. I didn't even know that. I grew up in Chicago, you know, and it's like, then I started thinking about all the radio stations. We had awesome radio stations in Chicago. Great music. But anyway, they all started with W. Isn't that the most interesting thing you've heard all day? Okay. So another thing you got to know here is that there's 26 letters in the alphabet. I mention that because not everybody in the class is a native English speaker, and people use very different alphabets. So instead of talking about PIN numbers and phone numbers, we're going to talk about radio station call letters. And what I want to know is the following. How many radio station call letters are possible if the first letter is a K or W, and for part A, no repetition is allowed. Now, in real life, you can have repetition, right? I mean, just like with phone numbers, you can have repetition. But this is just to allow us some room to play. All right. Notice this first letter is a K or W, just holds throughout this whole example. Do you agree I have 4 important choices to make? Okay, what are my restrictions? Well, the first one is a K or a W, and the rest of them, I can have no repetition. You with me this far? Cool. Where do I start? I start with the K or W. That's my most restrictive place. How many choices do I have for my first letter? 2 of them. Okay. Honestly, though, depending on the side of the Mississippi, we actually don't have a choice. So let's just pretend we do. Okay. So I picked my K or W. Now I have no repetition from here on out. I had 2 choices here, but how many did I pick? 1 of them. So if I start out with 26 letters and I chose 1 of them, how many choices do I have for my next letter? 25. Right? We had 2 choices here, but we only actually selected 1 of them. So if I selected my K, That means I'm free to use a W. Well, I started out with 26 letters. How many letters have I used? 2. So how many choices do I have for here? 24. And now I've used 3 letters. So how many choices do I have? 23. And if you multiply across, you'll see that you get 27,600. Now, this is using the multiplication principle as we've done it, okay? I just defined the permutation. So if you're wondering, well, Lord, what if I felt like using a permutation to do this? Let me show you how you would go about thinking about it. I claim, at least in my humble opinion, it's more work to do it that way, and I'm always about less work. But I like to show people all the different options that they have in case it jives better in your brain. Okay. So the way you would do this is, number one, I think you'll grant me that the order matters, right? Just kind of like with phone numbers, the order matters. With PIN numbers, order matters, right? You can't be like, well, I know there's a 4 in my PIN somewhere, so I'm just going to press it now while I'm thinking of it, right? The order matters in these things. If you are using permutations, you have to separate these. Notice we can use a permutation here precisely because no repetition is allowed. Okay, that's the extra thing that you have to pay attention to. So you have to separate it into 2 different permutations. Again, this is not something that I would do personally, but don't let me stand in your way. So to deal with this first business, how many choices did I have here? 2. And how many would I pick? Didn't we just pick one of them? So the way you would do this is you would do a permutation. You have 2 choices and we want to select 1. Now for the separate part, in other words, the part that's only bounded by no repetition, you have to do another computation. Here, you already have to take into account that we've used 1 letter. So we have 25 to choose from, and we need 3 more choices. I don't think this is as intuitive, because in order to get to this 25 right here, I claim you've already done it when you dealt with the multiplication principle. It's just too much thinking in my book. And I don't say that very often. All right, what if I tell you this? Repetition is okay. Again, my first letter needs to be a K or a W, but from there, I'm cool with whatever. So K or W, and I'm not going to write anything here. Well, start with the most restrictive place. How many choices do I have for my first one? 2. Do I have any limitations for the next one? No. So how many choices do I have? 26. Do I have any restrictions here? Nope. So how many choices? And 26. Holy smokes, 35,152 if you multiply across. In this case, you could not have used these permutations precisely because repetition was allowed. Let's do one more for today. All right, same thing, but now I'm just going to be more of a pain. I'm really good at that. Okay, so how about it must start with a K or a W. It must end in an R. Have a great day. And no repetition. So we got K or W, that's got to be an R, and we have no repetition. All right. What's my most restrictive place? Totally the R. In how many ways can I pick an R? One, I pick it. Next most restrictive place. You even gave me the answer as you said, Sia. You're on it, man. Okay, now it must be a K or a W. Yes, we do have the case that no repetition is allowed, but we only have two choices because the R is a non-issue. You with me here? All right, now let's jump to the next one. Okay, what are my restrictions? No repetition. How many letters have we used? 2. Good. We've used an R and a K or an R and a W, but either way, we've only used 2 letters. So don't we have 24 choices here? And then 23 choices here. And in case you really care, that brought it all the way down to 1,104. You want to see what a pain in the rear it would be to compute this using permutations? Okay, if you don't want to see it, don't look. Like, that's cool. Okay, you would have to do these things separately. Here, not really anything to compute. We had one choice and we chose it. For this first one, how many choices did we have? 2, and we chose 1. And then for this middle grouping, how many choices did we have to start out with? Well, how many letters have we used? 2. So we had 24, and we needed to choose 2 more. You have to take into account these R's. If you understand this and this baffles you, don't look at this. Okay, there's no need. All right, so what I'm going to do tomorrow is I am going to do just a couple more things in this section. And then we're going to move into lesson 3. I hope you all have a beautiful day.